on both sides. So from a table, how could I look at those data values in a table and determine my K value? Arunqui? Absolutely. All I have to do is divide y by that x value that associates with it if I'm looking at a table. So I see this table right here, and this is an example of direct variation, and it kind of makes me think about Michael, my husband. He really likes ice cream, but he would tell you that it's not ice cream, it's low-fat frozen yogurt. And his distinction comes from the fact that low-fat frozen yogurt has half the calories, which to him means double the dessert. So knowing him well, I know that there's 3 that he loves. He likes Coconut Road, he likes Moose Tracks, and he likes Neapolitan. He likes Neapolitan ice cream so much. When he looked at my dress this morning, he's like, "You look like Neapolitan ice cream." And so I was like, my husband really, really likes ice cream. So he has those 3 that are like his go-to flavors, and we always have them in the house. Well, my dad likes ice cream just as much, except he would say, "I like chocolate on chocolate, and I like chocolate on chocolate with chocolate sprinkles on top." So, but he'd say he has 3 favorites too. So Michael would have 3 cartons of ice cream with him everywhere he went if he could. My dad would have 3, so when those 2 are together, how many cartons of ice cream am I talking about? 6, very good. What about if my brother comes into the mix and he likes it just as much as everybody else does? Noah?
9.
We would have 9, that's right. What if I didn't have anybody in my situation at all? How many cartons of ice cream would I have? Marcus? 0, that's right. So I see this relationship building, but I've got 0, 0. What point on a coordinate graph represents 0, 0 in this situation, Andrea? The origin, very good. So I know that direct variation has to include the origin, and what will that graph look like? What function will it model? Yamilet? Linear, that's exactly right. So I can see this over here. I do want to glance, because we were talking about tabularly and had just a teeny bit of confusion. So let's go back to that y divided by x thing for just a second. What's 3 divided by 1? Aiden?
3.
3. What's 6 divided by 2? Graham?
3.
3. And what's 9 divided by 3? Jace? 3. What's my constant of variation? 3. Very good. Now this graphical representation is not for this table, but it's a great example of what we can do with direct variation. Is it linear?
Yes.
Yes. Does it go through the origin?
Yes.
Yes. A lot of times we think about the first quadrant and that it's positive, and that's true for direct variation. But it's not always positive. It's not always in the first quadrant. So I wanted you to see this one. So now we're going to inverse. Remind me what the equation for inverse is. Ryan. Y equals K over X. So if I wanted to solve for my constant of variation in this one, what would I do to get that K value, Tyler?
Multiply by x on both sides.
That's right. I can multiply by x on both sides. So in terms of K, what's the relationship that's going on with x and y, Raja? That's right, x multiplied by y is equal to k. So if I look at a table of values, what can I do with those x and y values to determine if it's inverse variation, David? I can multiply them together, very good. So if I look at this table for inverse variation, this kind of models a trip to Gaffney. So Gaffney's where I'm from, and it's 120 miles away. If I was talking to you, let's think about the equation that would model this. If I was talking about the distance I travel, the rate by which I travel, and the time it takes me to travel there, what's the equation, John David? D equals RT. Distance is going to equal rate times time. In terms of a constant of variation, for distance equals rate times time, what is my K value in that situation? A retweet? The rate, could my rate change as I drive to Gaffney? Yes. What can't change as I drive to Gaffney? Go ahead. If I speed up, would my time change? All right, so what does it change about Gaffney? The distance. Gaffney's always where it is. It doesn't say, oh, you got to come find me. I'm like, it's right there. My distance getting there is always going to be the same as it will like coming back. But Gaffney from Columbia is always going to be that same. Now, if I was in a different city, that would be different. But from Columbia to Gaffney, that distance is the same. So as I think about this, it's 120 miles to Gaffney. And I always follow the speed limit. I am very big on making sure that I follow the rules. And so if the speed limit says 35, that's the limit. I'm not going to go over 34. So when I drive to Gaffney, I go like 60 miles an hour. So I would tell you it takes 2 hours to get to Gaffney. Now, Michael drives a little bit faster. He has the belief that 5 miles over the speed limit is not actually speeding. So he normally goes about 75. I say, So he'll go about 75, and so it would take him maybe 1.6 hours. My mom is so sweet. She is one of the nicest people in the world. But if I look over and say, Mama, you're speeding, she goes, who But what did y'all tell me I can do? So this makes sense that it should be because my distance is the same. I multiply my rate and my time. So what can I do to make sure this is inverse variation? Yes, sir?
Substitute the numbers into our equation.
All right, we could substitute them into our equation. So ultimately, what operation am I doing, Willem?
Multiplication.
Multiplication, that's right. What's 2 multiplied by 60, Maddie? 120, very good. 75 multiplied by 1.6, a couple people have calculators. What did you get? Looking for somebody I haven't been able to call on yet today. Got a lot of familiar hands. Brianna. 120, very good. Quinlan, help me with this one. 80 multiplied by 1.5. What's 80 multiplied by 1? 80 multiplied by 80, absolutely. What's 80 multiplied by 0.5? 40, and 80 plus 40 is 120, very good. She snuck ahead on me. Yeah, so we get 120. So was this inverse variation?
Yes.
Yes, it was. Very good. And so here would be an example of a graph that would model this. So where was one point that direct variation absolutely had to go through, Willem? The origin. Daniel, does inverse variation go through the origin? No, it doesn't. And that's something important for us to think about. The origin can be the y-intercept for a graph, right? Yeah, what's the x value for any y-intercept that exists, Tyler?
0.
It's 0, that's right. Well, if I think about this equation, that would give me y equals k over 0. Am I allowed to divide by 0? No, and I realize that if it was the origin, my y value would be 0. But if I'm just talking about a y-intercept in general, x would be 0. When I divide by 0, be very careful with this answer. What do I get when I divide by 0? Got some people thinking, Ryan? It's not 0. Brianna? It's no real numbers. I would actually say, think about slope. I would say that answer is, John David? Undefined, that's right. Ryan, 0 divided by any number is going to be 0. But if I divide by 0, then I'm going to get, it's undefined. I'm going to have no solutions. So we realize that in inverse variation, we won't have a y-intercept. Is everybody okay with this? All right, very good. We're moving to our next slide, which is a Venn diagram. Can I get a volunteer who can write on the board for me? Raja, will you do my writing? You got it right quick. You up to the challenge? Yes, he's got it. So I want you to tell me, when we're talking about direct variation, if it's only direct variation, it's going to be on the left. If it's only inverse, it's on the right. And everything in the middle is what they share. Luke, what's one thing that would go in the middle?
Those could be graphed with a table.
All right, so they can both be graphed tabularly. So we can say graph, or we could use a table. What is a part of their equation that both have in common for this one, Will? They both have K. Very good. What? Is there anything else thinking about equations that both have, Daniel?
They both equal y.
Well, the regular equation, but what variables are involved?
Y.
They both have x and y variables. Very good. All right. Who can tell me something solely about direct variation? George?
The equation is y equals k multiplied by x.
Very good. My equation is y equals k times x. Graham?
The inverse operation is y equals k divided by x.
Very good. Y equals k divided by x. Luke, what can you add?
Direct variation goes to the origin.
Goes through the origin. We got Roger's bouncing all over the place. Very good. It goes through the origin. Anybody else? Oh, Aiden?
Oh, well, I know
Sorry, in your way.
that inverse variation does not go through.
All right. So to make it easier on Roger's, maybe we'll say not origin over here. Will?
Inverse has no y-intercept.
All right. So there's no y-intercept. Luke?
Direct variation is a linear line.
It is linear. Very good. Yep. And then, Tyler, you got one more?
For inverse variation, it would be quadratic.
Well, it's actually not a quadratic. It's not linear, but it's not a quadratic. What can we say? It's just a, will be really simple. Starts with a C. Noah? You can use what he said. Starts with a C.
Can you repeat it?
What could be a simple way we could describe that graph? It's not a line, it's a
correlation.
oh no, George. A curve. Yeah, you got it. It's okay. It's okay. Very good. Raja, you did a great job. Is everybody good with seeing some of the similarities and differences that happen with variation? Any questions from this one? All right, then let's look. We ready to switch? Yeah, thumbs up. Very good. All right, so within your long 1, 2, 3, 4. I want you to think about this. I want you to graph the following coordinate points. How are you going to graph them? What do you have? Yeah, come on, fun. What do you have? A graphing calculator, that's right. Graph the following coordinate points to determine whether they express direct, inverse, or neither. Direct, inverse, or neither. Now, if I graph it and I'm like, oh, it kind of looks like this one, what can I always do because I have a table? How can I check my answer, Willem?
Use the equation we have and multiply x by y or divide x by y.
Right, well, at first
Y
he
by
said,
x, sorry.
all right, y by x, right. Aiden, he started by saying equation. Are you given an equation for this one? For any of these?
No, not necessarily.
No, we're not giving an equation. But then he said, wait, we can divide our y value by our x, or we can multiply them. So that's what I want you to do. I'm going to give you about 90 seconds. Remember, y'all are doing problem 1, problem 2, problem 3, problem 4. You're identifying is it direct, inverse, or neither. And then when you look at that graph, if you need to double check it, you can consider the table. So you're good to go. 90 seconds. No, it's okay. All right, let me see what you got. You're number 3. It's okay. So you are right there. All right. It's okay. So 1, that first column is going to be 1. Yeah, absolutely. But that's okay. You are right about 4. All right, and so you did that. Can you use the calculator to plot those points for me for number 3? All right, what you got? All right, so is it, what can you obviously tell it's not? It's not linear, so it can be what type? How are you coming? Pretty good? Is it coming okay there? We'll try to plot them. Okay, so do you have your graph on your calculator? Yeah? No? Alright, so we want to go to your, should I see it for a second? So you help me get there. You want to go to your list right there. So scrolling over. Yep, and so that you can type that data in. Very good. Alright, we got about 10 more seconds. How you coming? Okay, yeah. All right, and so you started doing others. That's great. You started doing some others. All right, here we go. Clap once if you hear me. Twice if you hear me now. Very good. All right, this column over here, y'all had number 1. What did you say it was going to be, Luke?
Direct variation.
Direct variation. Very good. John, if I think about direct variation, what's the relationship between y and x? I would do what with y? Divide y by what? By x. Very good. If I think about quarters, how many quarters are in $1? 4. Very good. So with that knowledge, 10 divided by 2.5 would be what? 4. So what's negative 10 divided by 2.5? Negative 4. What's negative 20 divided by 5? Negative 4. And hopefully those of you who are checking it, other people had an opportunity. What's negative 30 divided by 7.5? Negative 4. Very good. This one was direct. Number 2. What'd y'all come up with? You thought it was direct for this one also? Okay, so let's look at it. What y'all think? Neither. So let's consider. If we're thinking about direct, what's 0 divided by negative 3? 0. What's 3 divided by 1? 3. What's 6 divided by 3? 2. 2. Do I have a constant of variation? No. And if I were to multiply, 0 multiplied by negative 3 is? 0. 3 multiplied by 1 is? 3. So is this one either one of them? No. This one's going to be neither. It kind of looked like a curve when you plotted it, but that's why we want to check our table values. All right, groups 3. What are y'all thinking? All right, so let's look at this. If it's inverse variation, what's the relationship between y and x, Noah?
Y for y is k divided by x, or
all right, so that's. Sorry, go ahead.
or y
let's think about this. 16 multiplied by 9, what did you get? Willem?
144.
144. I don't know 11 multiplied by 40 off the top of my head, but what's 10 multiplied by 40? 400. Is 144 the same as 400? No. So could that be inverse variation? No, because I don't have a constant of variation. So what must this be?
This is inverse. I mean,
No, we just proved it. Sorry?
Sorry, it's neither.
It's going to be neither, right? You could look at it and see there was a curve, because immediately Marcus goes, well, it's not direct when I was sitting here, because he goes, it's not linear. And we can tell it's not inverse by multiplying those values. Is everybody okay with this one? You get these values down, even if you didn't have this problem, so you can look back over them? Very good. Column 4, what did y'all get for this one?
We got inverse.
Inverse. Both groups are saying that. So inverse, what's going to be somebody over here, because y'all didn't have inverse, what's the relationship between y and x?
Y multiplied by X.
Y multiplied by x equals k. Very good. 50 multiplied by 2 is 100. 12 multiplied by 8 is 96. Yeah. 12 multiplied by 8 is 96. What's 0.5 multiplied by 8? Daniel? 4. Very good. And so, Brianna, what's 96 plus 4? 100. That's what gives me 100. I'm doing partial products right now, so you can multiply them in your head. So 40 multiplied by 2 is what, Jace? 80. And Quinlan, what's 0.5 multiplied by 4? 20. And Graham, 20 plus 80 is 100. Very good. So did we confirm it's inverse? Yeah, we can tell it wasn't linear. It's looking like a curve, and then we can check it that way. Do I have any questions on this page right here? All right. So to our last thing or our next thing that we're going to come to, George.
Right now, to get the right variation, you divide.
Mm-hmm.
And then
Well, what do we divide? What are the values that we're going to be dividing?
X and Y.
All right. So which way? Is it x divided by y?
I think it's Y.
You're right. It's y divided by x because we have y equals k multiplied by x. So isolating that constant of variation. Is everybody with me? That's wrong about this? Yeah. To get that constant of variation, we have y divided by x. Great question. George had actually been working ahead and doing some of the other problems while we were here. So the next thing we're going to do is you're going to classify each of the following as direct, inverse, or neither. We're going to do the same thing you did, but with a different spin. This time you're going to justify. Justify means to what? To, well, support, explain, Brianna? Prove, yeah. So you're going to prove to me, you're going to explain, you're going to support what this is tabularly, graphically, and algebraically. So the three that you're going to consider are Mahira gets paid $10 per day to doggy sit Finley. The next situation is that x sub 1 equals 6, y sub 1 equals 27, x sub 2 equals 10, I'm going to slide out of your way, and y sub 2 equals 45. And then lastly, we have that Lynn has 24 cupcakes to share among her classmates. So you're going to work with these within your individual student learning community. So breaking down to smaller groups for this one. Do you have any questions that you need me to answer before you get started? Anybody? All right, y'all are good to go.